Hey guys, let's do some solving of equations. What I mean by solving of equations means that you are trying to find the value of the variable that makes the equation true. So for example, in our first equation, we have 5x equals 15. I have to find out the value of this variable. I have to figure out what that x equals. And in order to do that, I'm going to use something called inverse operations. Inverse operations is just sort of the opposite. So the inverse of addition is going to be subtraction. The inverse of multiplication is going to be division. And the same thing, the inverse of subtraction is addition, the inverse of division is multiplication. Those are your inverses. And we're going to use those inverse operations to help us solve for the variable. In order to solve for the variable, we have to get the variable on one side of the equation by itself. We call that isolating. I have to isolate my variable. That's where those inverse operations come in, is because we are going to undo whatever is being done to that variable in order to isolate it. So for example, on this first one, 5x equals 15, I know, again, anytime I have a number next to a variable, that means that I am multiplying. Okay, so since I'm multiplying x by 5, that means I have to use my inverse, which is division. I have to divide them by 5. You'll notice my dividing by 5 looks a whole lot like creating a fraction. There's a reason for that. Fractions are simply division. Okay. When I do that, I create the fraction 5 over 5. Well, 5 over 5 is just the number 1. It's like 5/5 is the number 1. So I'm left with just my x. I'm left with one x. Notice how it's by itself. I've isolated that. But then in order for these to still remain balanced, in order for them to still remain true, if I divide one side by 5, I have to divide the other side by 5. So 15 divided by 5 is what x is going to equal. Well, 15 divided by 5, I know is 3. So x is going to equal 3. Now I can check that by taking this value of x and substituting it back in. So I can take 5. I'm going to substitute in 3 for that x. So instead of writing x, I'm going to write times 3. Okay. And then I'm going to see, does that really make it true? Is 5 times 3 15? Yes, it is. So I know that's true. On our second example, same sort of thing. Okay. You'll notice I have x and then a slash and a 5. Okay. Same sort of thing as writing it this way. It's creating that fraction. And remember, fractions mean division. Okay. So this is x divided by 5 equals 5. In order to isolate that variable, in order to get it by itself, I have to do the inverse of division, which I know is multiplication. So I'm going to multiply both sides by 5. Again, I have to do both sides so that they stay even. Okay, by multiplying both sides by 5, I again create that fraction of 5 over 5, which gives me 1. So it just gives me x equals 5 times 5, which is 25. Again, I can check that by substituting that value back in for x. So let me check it again. 25 divided by 5 does equal 5, so that I know that one is solved correctly. My third one, x plus 13 equals 39. Again, right now I'm adding 13 to it, so I have to subtract 13 in order to get that x by itself. But again, doing it to both sides, 13 minus 13 is just 0. So I'm left with x by itself. And then 39 minus 13, I find out that x equals 26. Again, I could substitute that in. okay, is 26 plus 13 39? Yes, it is. So that checks out as well. The last example I have takes a little bit more steps. It's called a two-step equation, which means it takes two different steps, two different inverses that I have to use in order to isolate that variable, in order to get x by itself. Anytime you have a two-step equation that you're solving, you're always going to start with your constant. You're always going to start with that number that's by itself, not attached to a variable. So the inverse of subtraction means I'm going to have to add. And again, still have to do the same thing to both sides. -3 plus 3 gives me 0. So now I'm left with 5x equals 20. Here's the second step. This is why it's called two-step. 5x means I'm multiplying x times 5. In order to get that x by itself, I have to isolate that variable. I have to do that inverse. The inverse of multiplication, I know, is division. I'm going to divide them both by 5. 5 over 5 is 1. So I find out that x equals 20 divided by 5, which is 4. Again, if I substitute that back in to my original problem, let's see if it's correct. So 5 times 4 minus 3 is what I'm trying to figure out. Okay, order of operations tells me I have to do the multiplication first. 5 times 4 is 20. Minus 3 is 17. So that checks out that x equals 4.